We are continuing section 5.2 today. So yesterday you had the first notes and 6 homework problems, and we're going to just do more of the same today. Just more examples and a few more problems for you to try on your own. Make sure you're staying caught up with this each day and letting me know if you have any questions so I can help you along the way. A couple comments, things I noticed when people were sending me their work. Make sure you are following the format that I asked. So when you write down the problem, I do expect you to write down both sides of the equation, and I do expect you to show me which side you are boxing in so I know what you're working and when you get there. Okay, so we talked about picking a side and boxing it in, saying which one looks simpler. So looking at this, it's kind of a toss-up. You know, do you like the fraction or do you like things multiplied? It's not an obvious, this is easier than that. So let's say, for lack of a better option, I just boxed in the right. Working with the left, our strategy is usually, unless we pick out some big formula, just change to sines and cosines. So tangent, it would be sine squared s over cosine squared s. Secant would be 1 over cosine squared s. We know to divide fractions, we flip and multiply. When I do this, my cosines drop and I get sine squared s. You may see how to get to the final answer from here and you may not. It's going to vary person by person. One option, if you recognize it, you can change your sine squared to 1 minus cosine squared. And then, remember, algebra techniques work. This is the difference of squares. If I gave you x squared minus 9, you would factor that into x plus 3, x minus 3. So if I give you 1 minus cosine squared, that factors into 1 plus cosine s, 1 minus cosine s. But that may not have been obvious for you. So if you got to this point, that's great. You boxed it in. You should have 2 boxes on your paper. We've got our answer. But let's say you didn't. Let's say you got to this sine squared and you didn't know how to get to here. If needed, you can actually work both sides of the equation. Now, to help me, what I need you to do, if you decide you have to go back and work the other side, go ahead and just erase your box. And then I'm going to come up here and work this side. So I worked the left as far as I could get. I'm stuck. I'm going to stop and box in sine squared s. And now I'm going to work the right-hand side and get sine squared s, hopefully, and then I can box that in. So again, you'll have 2 boxes that match. Make sure, if I am looking at your paper, that I can understand what you did. So if you just have a string of equal signs, and then you keep going with this one with more equal signs, I'm going to be very confused. Try setting up some columns or something, drawing a line between the 2 sides, so I know what you're doing. So on the left, if we FOILed, we would have 1 minus cosine and plus cosine drop, minus cosine squared s, and 1 minus cosine squared is just sine squared s. And so my 2 sides match, and I've got it. So first strategy, box in one side and work that. If you get stuck, box in where you're at, go work the other side and see if you can get it to the same point. Okay. Let's take a look at this one. This is really just an all-around ugly problem. The 2 sides are pretty equivalent. No one is easier than the other. If you take a second, just watch me for a second. Don't write this down. We could change, you know, secant to 1 over cosine, tangent to sine over cosine, divided by our sine. We can add these together because they have a common denominator. To divide by a fraction, you flip and multiply. But I'm really getting no closer to where I want, because I still have things added on the top. On the bottom, I have things multiplied and I want subtraction. So this one is actually kind of hard to get to using the strategies we have been doing. But there is another option. Let's just pick a side and box it in. I'm going to box in the left. If you notice, the numerator on the left and the denominator on the right are very close to one another. They are conjugates. Sometimes it might be helpful to add something new into your problem. In other words, when we dealt with radicals, if I gave you something like this, we talked about you multiply by the conjugate to get the radical off the bottom. If I want to get this off the bottom, we might try multiplying by the conjugate and seeing if that gets us anywhere. So I am going to multiply by secant s plus tangent s on top and bottom over here. Okay. On the numerator, my goal is to have a secant s plus a tangent s. So I'm just going to leave that. I'm not going to distribute my cosecant through. On the bottom, if we FOILed, we get secant squared s plus secant tangent and minus secant tangent cancel, minus tangent squared s. Okay. We're in better shape than we realize right now. Remember your identities? Tangent squared theta plus 1 equals secant squared theta. That's on the formula sheet that I'm giving you. We have secant squared minus tangent squared. Well, if you subtract over your tangent squared, secant squared minus tangent squared is 1. If you got stuck on homework problem 43 yesterday, this is probably where you got it. You simplified the left and you got 1, and you were trying to prove that it equals secant squared minus tangent squared, and it does from the identity. So I am going to change my denominator to just a 1. I'm also going to change this cosecant to a 1 over sine. Since this is over 1, I can really drop that. So I have secant plus tangent times 1 over sine. So that's just secant s plus tangent s over sine s, which is what I wanted. It may not always be obvious to you from the beginning what to do. You might start a problem and get to the point where you realize this doesn't look anything like what I want. I need to start over. And that's okay. I would recommend not erasing everything, maybe just going down below and reworking the problem, because you might find something that clicks or catch a mistake you made in the earlier piece. But there are lots of strategies that we can use, factoring or multiplying by conjugates. So we have to keep our options open here. Don't get frustrated if you don't get the answer immediately. Okay, let's try a couple more. We'll have another ugly one here. Okay, so we have some options. I think both sides are pretty ugly. There's no real obvious, easy place to go. I like sines and cosines better than I do cotangents and cosecants, so maybe I'll make this my goal. But I know that if I get stuck, I might have to change that plan. So cotangent is cosine over sine minus cosecant is 1 over sine over cotangent, cosine over sine, plus cosecant, 1 over sine. I have a common denominator on top and bottom so I can combine, so this is cosine theta minus 1 over sine theta, and cosine theta plus 1 over sine theta. In order to divide fractions, we flip and multiply. Or another strategy that we talked about a couple days ago was you could just multiply top and bottom by the same thing. So I'm going to multiply top and bottom by sine theta. So these cancel. And I get cosine theta minus 1 over cosine theta plus 1. Okay. Definitely prettier than what we started with. Definitely not where I was going for my final answer. If you recognize how to turn this into your final answer, that's great. If you don't, you can come up and start working this side and seeing if you can simplify it to the same thing. I'm guessing most of you probably can't just look at this and understand how to get to that point, so what I'm going to do is come up and work this side. So I'll box this in, draw a line, show myself I'm working the other side, and I'm going to try to get the same thing. The numerator. If it helps you, that's like cosine squared minus 2 cosine plus 1. This is just a box method problem. Okay, we can factor it as it's written. You could rewrite it, but we don't have to. Cosine squared just breaks into cosine. Multiply -2 and add, multiply to 1 and add to -2 would be a 1 and a 1. So we have 1 minus cosine and times 1 minus cosine. If you factored it the other way, if you rewrote it, then you would factor it into cosine theta minus 1 times cosine theta minus 1. It's okay, either way, you're going to get the same answer. Sine squared. Remember, we have this identity. Sine squared theta plus cosine squared theta equals 1. That means sine is equal to 1 minus cosine squared. So I am going to replace my sine squared with the 1 minus cosine squared. One minus cosine squared can be factored. That's a difference of squares. That factors into 1 plus cosine and 1 minus cosine. So these drop. Look at our goal. Cosine theta minus 1 over cosine theta plus 1. If you have a negative, you can distribute it through the top or the bottom. The bottom right now is good. 1 plus cosine is the same as cosine plus 1. So I don't want to take my negative through the top or through the bottom. I'm going to distribute it through the top. So that would be a -1 plus cosine theta over 1 plus cosine theta. That is cosine theta minus 1 over cosine theta plus 1. We have our answer. Okay, definitely the most challenging problem we've done today. So if you need to take a second and rewatch any of that, please do so. One final problem for today. I think we can all agree that the right-hand side is nicer. So I'm boxing in the 1. That's my goal. the left. Sine squared plus cosine squared is 1, but minus isn't a formula, so I can't do anything with that. If you notice on the numerator, that is a difference of squares. Actually, they both are, numerator and denominator. On the numerator, if you have sine to the 4th, we'll break into sine squared. So we can do sine squared plus cosine squared and sine squared minus cosine squared. I could factor the denominator, but I'm not going to, because right now these already cancel, so I don't want to break it down anymore. So I'm left with sine squared plus cosine squared, which we know is 1. Okay, so I've worked through some more problems with you today, some more challenging than others. I'm asking you to try 6 more problems on your own tonight. There's 1 or 2 that are a bit more challenging, but given that we are not actually in class, I tried to give you some that I think you can easily get on your own. Please don't hesitate to let me know if you have questions. I am actually going to continue this section on Monday as well. So on Monday, I will give you a few new problems. And then the 5.2 homework, all 3 days worth, will be due on Tuesday. So Tuesday I am moving on, kind of. I'm not doing a new section, but I would like all of these 3 days worth due on Tuesday. So just keep up doing your 6 problems each day, and you should be caught up and be able to get that into me no later